Okay. Ladies, if you just want to go ahead and take out your chapter 3, we're just going to start with the notes here in just a second. All right, so chapter 3.2, we're going to solely concentrate on this concept called correlation. Yesterday, we talked about, or we looked at a scatter plot, and we talked about the strength, the direction, and the form. 3 descriptors that we would use to describe, our scatter plot. Now, with the direction, you can kind of see by the pattern a little bit, but sometimes as the points were a little bit scattered out, it got a little bit harder to see. Okay? And then for the strength, sometimes we'd start to kind of argue about, well, is this really strong or is it weak? Do you say that it's really strong or very strong or just moderately strong? How do you go about truly quantifying it? And that's what we're going to be solely focusing on today, and that's this concept called your correlation, or otherwise known as your correlation coefficient. Whoa, I hate it when it's on this mode. It always starts in this mode. So correlation coefficient is represented by this letter R. So lowercase r that we'll always use for it. There is a complicated formula to it, which basically involves z-scores. You're going to standardize your x's, you're going to standardize your y's, you're going to multiply them together, and you're basically going to take the average of them. Now, if you followed that, okay, more power to you. With correlation coefficient, you'll never have to calculate it out, okay, by hand. I don't even demonstrate and show it to you because it's a very clumsy formula. It takes a long time to actually do. However, with our technology that we have, your calculator does it lickety-split. Okay? So, but it's important to know what the correlation coefficient represents and how you go about interpreting it. Your correlation coefficient, okay, has some facts about it that I'm going to kind of talk about, and I'm going to kind of be jumping around here. Okay? I'm going to go down to number 6 just to start. Okay? Your correlation coefficient, what it does is it helps you measure the strength and direction. And when you plug in the values into this, or when your calculator plugs in the values into this particular formula, it's going to give you a number between 1 and -1. Okay? The closer that it gets to these values, the stronger your linear relationship is. If you get a correlation of 0, it doesn't mean that there's no relationship. It just means that there's no linear relationship. And there'll be a problem today in the CFU that will actually show you this, that you'll get a correlation of 0, but yet you'll see that there's a obvious pattern to your points. It's just not linear. So what will happen is you're going to get a number. And so students always want to have some sort of kind of guidance. So what I tell students is whether your number is plus or minus, okay? Doesn't matter if it's plus or minus. If your value, say, is between 0.85 and 1. I tell students in the description to write something like, use the words for the strength as very strong. If it's between, say, about 0.6 and 0.84, I would say like moderately strong. If it's between, say, 0.4 and 0.59, I would say, fairly weak or moderately weak. And if it's between, say, like 0.2 and 0.39, I would say very weak. And if it's between 0 and 0.19, I usually will say little to no association. Now this applies to both the positive values and the negative values. What's nice about correlation is, if it's positive, you have a positive association. If your correlation coefficient R is negative, you'll have a negative association. And that actually, I believe, is number 4 right here. So when we kick out those R values, if R is positive, the association is positive. If R is negative, your association is negative. Okay? Now, when you do correlation coefficient, and we're basing it on a scatter plot, both your variables must be quantitative. Okay? So you've got to be able to do a scatter plot. You can't get a correlation coefficient for categorical data. So like our CFU yesterday, the first question talked about survival times in 2 different types of cancer treatments. Since the 2 different types of cancer treatments are actually categorical data, we could not calculate out a correlation coefficient for it. Okay? Now, just to kind of cover a few of these other values, or these other things to know. Correlation has no unit measurement to it. Unlike standard deviation, or variance, or mean, it has no units attached to it. Okay? So it's just a number between -1 and 1. Okay? Here's kind of a cool thing that we'll show you in a little bit. Correlation makes absolutely no distinction between the explanatory and response variable. So if you flip them around, you'll still get the same correlation coefficient. It does impact other things if you flip them around, but the correlation coefficient doesn't change. Likewise, because we're standardizing it, because the formula involves z-scores, okay, if you decide to change the units, say if you decide to go from inches to feet, or minutes to hours, okay, correlation coefficient will not change. Okay? Last but not least, the last couple 2, okay, correlation, okay, only measures the strength of a linear relationship. So when we're talking about correlation, we're only talking about linear relationships. And number 8 we'll demonstrate for you here today is R, or correlation coefficient, is like your mean and standard deviation in that it's not a resistant measure. Just simply changing one data point and its location can change your correlation from a positive to a negative. Okay? Can change it from being very strong to very weak. That's how sensitive this formula and this value can be. Now, let's actually talk about how we get these values on your calculator. Here's your directions right here on your calculator, and I'm going to pull up my calculator too, okay? And we'll go through some examples here in just a second. But one of the things that I want to make sure you do is make sure that you have your diagnostics on. The correlation coefficient only shows up if this diagnostics is on. Depending on your calculator, there's 2 ways to turn on your diagnostics. So, for most of you, if you have your calculator and you go to your mode, okay, so I want everyone to have your calculators and to check this, because next thing you know, after we do the first one, I hope that we don't have any hands raised on saying, I'm not getting my R value. Okay. So, what I want to do is go to the next page in the mode. Now, not all of you will have this, okay? But if you go to the next page and you see something that says Stat Diagnostics, okay? If you have that, make sure it's on. So highlight it. So like here, I can go down and highlight it and hit Enter and make sure it's on. Just out of curiosity, anyone not have that on your calculator? Okay. Mode. Scroll to the next page. If you don't have it showing stat diagnostics, then I need you to make sure you're paying attention to this next step. Okay? So for the next step is if you have an older version of a calculator, which some of my calculators that I still have is the older version. The other way you can get to it is by going second 0. This is your catalog. So if you hit second 0, this will get to your catalog. And then what you have to do is scroll down until you get to diagnostics. Or you could go alpha and then find the letter D. I just find sometimes if I just do it this way, I can get to it just as fast. So I'm looking for, because basically this is every single function that's in your calculator is in your catalog. So I'm almost there. Sorry, this is taking a lot longer. Here I have diagnostics on. I'm going to make sure my arrow's on it, hit enter, hit it one more time so it says done. Alright, so hopefully we all have our diagnostics on. If we don't, we'll know here in just a couple minutes. So now, if you flip over to the next page, we're going to run through some examples dealing with correlation and the correlation coefficient. So, in question number 1, it says match the given correlation coefficient values R to the correct graph. So I have 6 correlation coefficients there with 6 graphs. So what I like to do is look at the ones that look probably the strongest or the closest to being linear. Which of these graphs, okay, the bottom, this one right here looks very close to a straight line. So if you were to pick R, the correct R, which one would you pick? Okay, 0.9, or would you pick negative 0.99? Okay, why are you going to pick the negative? It is going down. So the negative gives you the association with it. So now the question is, if I look at these, I've eliminated the negative 99. I want to look at which one seems to also maybe be closest to being positive and linear. Okay, so I have a point, so the positive ones, I'll double underline them. I have 0.9, 0.1, and 0.5. So when I look at what I got left with my 5 graphs, which graph looks closest to a positive 0.9? Yeah, middle bottom. This one definitely showing a positive linear association. So I'm going to go with 0.9 with that one also. But just like that, we've eliminated 2 of them. So if we start to take a look at what we got left, okay, the question becomes, all right, do we have positive or negatives? Does this one look like a positive or negative association? Okay, negative. How about this one? Positive. How about this one? Probably negative. This one's hard to tell. So since we only have 2 negatives and 2 positives left, we're going to say that that one's positive, but really, really hard to tell. So now the question is, if I look at my 2 negatives, okay, the middle top here and this one here, which one's closer to negative 0.7? Top or bottom? Yeah, I'd go with bottom too. Negative 0.7. How about then this one would be negative 0.3. So now, of the 2 that we got left, which one looks closer to 0.5? One on the right. Making this one was the hardest one to see if it was even positive or negative. And that will happen when you get close to 0. It'll be really hard to tell which one is positive and which one is negative. Alright, questions with the first example. Because you're going to see graphs like this, and But what's nice is we'll use our calculator to calculate out the correlation coefficient. So let's take a look at number 2. McDonald's. That's just so mean to talk about McDonald's right before lunch, isn't it? Why now? All right, so let's take a look here. It says, over the last few years, many people have gone on low-carb diets. Others have tried low-fat diets. Here are the carbohydrate contents in grams and fat contents in grams for 9 different types of hamburgers at McDonald's. It says, discuss what the data shows between the relationship between the amount of carbs and the amount of fat in McDonald's hamburgers. Follow the 4-step process. All right, so we got to do the 4-step process here. So that's the state. What's that? In the McDonald's plain hamburger? Oh, go look it up. You know, we're talking their small little hamburger. I'm not talking the quarter pounder. All right? So we're talking, you know, the hamburger that comes with the kids' meal. All right? So, anyhow, first thing we want to do, right, is let's enter this data into our calculator. List 1 and list 2. So let's put all the carbs in list 1 and all the fat in list 2. And I believe I've already done that. So I go stat, and I go to my edit. Hopefully I have them all in there. Look at that, 923. What? That's not right. Oh, I know why. So that's list 2. There we go. 31.9, 33.12, so forth. I'll be quiet and give you a second to enter those in. Does anyone need any more time to get in the data in the calculator? Okay. All right, so now, 4-step process, state, plan, do, conclude. So again, we want to state what we're trying to find. I'm going to write, I'll actually write the words, though you won't necessarily have to write state, plan, do, conclude. But I'll do it for this one here. So in the state, we just want to note what we're actually trying to find. So we want to see if there is a relationship between the amount of carbs and the amount of fat in McDonald's hamburgers.
What's your favorite thing at McDonald's?
It's my favorite thing at McDonald's? Wow, good question. I love the strawberry shakes. Still do.
I love Shamrock.
Shamrocks are alright. I do like the strawberry. So, my daughter absolutely loves the McDoubles. I don't even know if they're here. I suppose it's probably the same as the double cheeseburger. So the McDouble's not even here. Interesting.
Where's the Big Mac? Oh, there it is.
There it is. That is a classic. All right, continuing on, we want to do our plan. So, in order to answer this question, what's one thing that I can do to get an idea of what's going on here? What did we do yesterday? Okay, make a... So we will make a scatter plot and calculate out the correlation coefficient. And that symbol is known as R. So because I know we don't have a ton of space, I'm going to do the do part up right by the data. So I'm going to sketch this by hand real quick. So here's my X and Y axis. So this is going to be carbs, and this is going to be fat. Of course, the measurement both is in grams. So if I look at my carbs, it looks like my carbs are only going from 31 to 45. So when I break this and kind of do my x-axis here, I'm going to do a break in my graph. I'm going to start at 30. And I know I'm only going to go up to 45, so maybe I'll just count by 3 since I don't have a ton of space. 33, 36, 39, 42, 45. My grams of fat are going from 9 all the way up to 42. So I might count by 5s up to 45. So 5, 10, 15, 20, 25, 30, 35, 40, 45. So even if I asked you, like for instance, on a test to graph one, I'd probably give you a data set maybe this big. We only have what, 2, 4, 6, 8, 9 hamburgers. That's not too bad to graph. So I'm just going to take a minute or two and graph these points. So 31 and 9, 33 and 12, 34 and 23, 37 and 19, 40 and 26, 40 and 42, wow, 45 and 29, 37 and 24, and 38 and 28. So now I'm going to use my calculator and take a look and see, is my graph matching up here? So let me shrink this just a little bit. It'll let me. Oh, I hate it when it starts doing this kind of stuff. There it is. I just want you to be able to see both. All right, so reviewing of the stat plot. Second y equals, we go to our stat plot. What's really nice is probably most of you still have this on from yesterday, on scatter plot, and hopefully it's on list 1 and list 2. Again, remember when graphing we go zoom 9. And how does our scatter plot by hand look compared to our calculator? Pretty good. You can kind of see how these 5 points in the middle here are bunch just like these, 2 down below and 2 a little more spread apart. So it gives us a relatively nice picture. Does it seem to be linear? Okay, definitely positive, potentially linear. So the question becomes, what's our correlation coefficient? So we need to figure out, how do we do correlation coefficient? So on the previous page it has those steps. So to get to it, you hit your stat key. Everybody on stat? Use your right arrow. Go to calculate. Go to number 4. Linear reg. A x plus b. You can choose number 8. There's 2 of them. I'm just going to choose number 4 for right now. Hit enter. Okay? The bottom value is your r. I'll do it again from start. So I go stat. Right arrow. Number 4. So I just hit number 4. And then I hit enter. 0.7337. Anyone not getting the R?
I got 0.74.
Just go down to calculate.
Yeah, you
Is there
did.
any way that could just cut that?
Ooh. There, you guys not getting 0.7337?
0.7433.
Oh, maybe Mr. Bartz has the data point incorrectly.
Yeah, and Bob will.
It could happen. Let's find out. Let's see. And this is how, just one little data point, so I'm going to check all my data points, because it sounds like you guys all have something different than me. Thought I checked. Aha, look at this. This should be what? 42, and I had 43. So now, stat, calculate, number 4. Do you get 0.7433?
Yes.
Oh, see, even Mr. Bartz makes mistakes once in a while.
Everybody makes mistakes.
Everybody makes mistakes. Just learning how to deal with them and move on. So our R, 0.7433. So the question that this helps us answer is, it gives us now a quantitative way of measuring the strength. I'm just going to flip back a page for just a second. So 0.73 falls into this moderately strong. So now I can go to my conclusion. So now I'm going to conclude. And our R value helps us support this. So we're going to use those descriptors when describing what's going on here. So we have a moderately strong, positive, linear relationship between the amount of carbs and the amount of fat found in McDonald's hamburgers. Oh,
So if it's not linear, is it going to be 0?
well, it's going to be pretty close to 0, and that's why graphing it is so important. You don't want to just solely base your answer on R itself, because there can be situations where R is, very close to 0, but yet there might be a really cool pattern going on. Or it might be really strong, but the reason why it's really strong is because a couple points are influencing it a lot. Okay? And we're going to kind of see that in this next example.
What's your range to make it so you know it's not linear?
Well,
If you know what a really weak one is, but then would you just say that's not linear?
what we would, if it's not linear, that's where the graph comes into play. If you start to, like, if these points had a definite huge bow going on into it, then you know, your R may or may not have you show that, but the graph will say, you know what, I got, you know, this looks like a curved pattern of some sort. It almost looks like it's, you know, exponential, or it might look like it's some sort of inverse model. Okay? Those are models we won't go into detail in this class, but we do in the other. All right, any questions with this page? All right, we're going to run through one more example that's really going to show you some of the key features of correlation and how correlation can definitely impact and change what's going on. Okay. All right, so if you flip to the next page, okay, it says the following data give the weight in pounds and cost in dollars of a sample of 11 stand mixers. This is from Consumer Reports back in 2005. So here's the weight of the mixer and how much it costs. So what I want you to do, I have them in list 3 and list 4. If you want to put them in list 1 and list 2, that's just fine. If you want to follow along specifically, I'm going to put them in list 3, excuse me, as I hiccup, and list 4. So I'll give you a minute to do that. And I'm going to take a minute and verify that my mixers in here are correct. So I don't have one typed in incorrectly like I did in the last one, which does happen from time to time. Whoops. All right, let me do this. I want to slide this just a little bit so I can see both. All right, 23, 180, 22, 250, 19, 300, 17, 150, 25, 300. Just check in 26, 370, 21, 400, 32, 350, 16, 200, 17, 150. How about that? 8 and 30. All right, so question A says, sketch a scatter plot of the data and describe what you see. All right, let's do that. So I'm going to shrink this just a little bit. Well, I don't want to switch. Let's go to 100% there. That's better. So I can see the data and still graph it. So make a quick sketch here. This is going to be the weight. And this is going to be the price. So it looks like weight is going from 8 to 32 pounds. And price is going from $30 all the way up to, looks like, $400. Yeah. So for the weight, since I still have a low of 8, I still probably going to put this at 0, 0. But I need to go up to 32. So I'm going to count by 4s. 4, 8, 12, 16, 20, 24, 28, 32. Price, wow, goes up to 400. I might count by 50s here. 50, 100, 150, 2, 250, 3. Oh, I'm going to squeeze this one up here. 350 at the very top. 400. So I'm just taking my time and graphing each of these points. So 23, 180, 28, 250, 19, 300, 17, 150, let's see, 25, 300, 26, 370, 21, 400, 32, 350, 16, 200, 17, 150, and then 830. So just based on our picture, one of the things we can do is, again, go to our calculator. If I go to my stat plot and I turn it on, what lists do I have to select?
3 and 4.
Yeah, list 3 and list 4. Now when I hit graph, I actually have to make, if I just hit graph, I probably won't get any points to show up, because I have to zoom 9 so that it fits nicely in my window. So we can see also by this graph, just like our hand sketch one, most of our points are sitting here, but we got this one little tiny point down in the lower bottom. So the question becomes, how does that impact our correlation coefficient and what we see? If you were to describe this relationship without even thinking about doing the correlation coefficient, just by a show of hands, how many of you would say this is strong? No hands. How many would say weak? Okay, we got a few brave souls raising their hands. So since we have a few, I might say too that we have a moderately weak positive association between weight of a mixer and its price. Right? Now, I haven't calculated out R yet. Go ahead.
So then, like, why are you saying it's like moderately weak when you don't know?
I'm just basing it solely off the picture right now.
Why would you do that?
Exactly. Why would I?
Because sometimes it reduces.
Okay? It's probably not a good idea, is it?
No.
Okay? That's why I'm doing it. Is to show you that, what happens when we calculate out R? Okay? I go stat, calculate, number 4. Whoa, what's wrong with this? Wrong list. So I gotta go stat, calculate, number 4. Now, here's the thing. I want it to do what lists? 3 and 4. So I have to tell it to do it on second 3, comma, second 4. So if it's not in list 1 and list 2, you got to tell the calculator specifically what list it needs to be in. Ooh. Do you get 0.7411?
Yeah.
Yeah. So down here in B it says calculate out the correlation coefficient, 0.7411. Okay. Now, this correlation tells me that it should be moderately strong. Okay? So when I have moderately weak here, that's kind of a question mark. Okay? Now, do any of these points seem not to belong with all the other mixers? Okay? This bottom one. I'm going to switch colors here for a second. I'm going to look at this one right here. Okay. It says the last mixer in the table is from Walmart. What happens when the correlation? What happens to the correlation when you remove this point? So what I'm going to do is I'm going to take this point 830 and I'm going to take it out of play. All of a sudden, this point is no longer being a part of our calculation. Okay? So let's see what happens. Okay. So I'm going to go to Stat. I'm going to go to my Edit. I'm going to go to List, bottom of List 4, and I'm just going to highlight 30, and I'm going to delete it. See how it removes the point 30? Highlight 8, and it removes. And if I hit delete, it removes just that point. Because I want to see how this particular point, okay, because this point was not like all the others, okay? One of these points is not like the other, sorry. Okay? So what I'm going to do is I'm going to basically remove it and just see, all right, how does that one singleton point change my correlation coefficient? Okay? So it says, what happens to your correlation coefficient? All right, let's find out. So now go to Stat, go over to Calculate. Let's do number 4. And again, we have to do it on List 3, List 4. So I removed that point. What's happened to my correlation coefficient? It went down. Did it go down a lot? Yeah. It went down to a 0.56. Sorry, I forgot the 25. 5625. Okay, so by removing this one point, we go from a moderately strong association to a moderately weak association. Would you consider that point an influential point? Yeah. That's how one little data point can change an answer. I agree with you. If I were including this point, I would definitely be saying moderately strong. But boy, take that point away, it becomes moderately weak. So this point causes your correlation to get much, much stronger than it might not actually be. Now, we're going to have some even more fun. It says, what happens to the correlation if the Walmart mixer actually weighed 25 pounds instead of 8 pounds? So we're going to add the point 2530 and recalculate out the correlation. So I'm going to, first of all, what we're basically doing here now is we're saying, all right, what if I put in the point 2530 and I put the point right here? So I'm going to take that point and I'm going to move it around a little bit. You're going to see how this can drastically change your correlation coefficient. So I need to add the point 2530. So I'm going to go back to my Stat, I'm going to go back to my Edit, go to the bottom of List 3. For the X value, it's 25. Hit Enter. Go over to the Y, or List 4, and enter in 30 for the cost. If you want, you can hit Graph, and you can see how the point has moved, okay, from down here in the bottom left to the bottom right. You can see how that point has moved. How does that change our correlation coefficient? Let's find out. Stat, calculate, number 4, List 3, comma, List 4, enter. Ooh. Now we're at what? 0.3364?
Yeah.
Okay. Are we moderately weak, or what has now happened? We're now becoming, we have a very weak association. Part E says, suppose that the new titanium mixer was introduced, only weighed 8 pounds, but it cost $500. Remove the last point in the data and in the data set and replace it with the point 500. So what we're doing now is this. I'm going to go to, let's see, what would be a good color? Purple. Now we're going 500. On my graph, I only go up to 400, so 500 is going to be like way up here. What do you think that's going to cause the data or the correlation coefficient to do? Now all of a sudden you got this point. Any idea what it might do? It might make it negative. Let's see if it actually does. Okay. So, I go to Stat, go to my Edit, go to the bottom of my list. I need to replace the point 2530 with 8, and then the 30 with 500. So now, Stat, Calculate, linear regression, list 3, list 4. Ooh. And we get a negative. So negative 0.0765. So now there is little to no association plus it went negative. Just that one point. One little point has that much power when it comes to correlation. So here it made it pretty strong. Here it made it fairly weak. Here it made it negative. Okay? So, in a nutshell, what patterns do we see about a single point on the correlation? Oh, it changes it drastically. I like that. It can change the correlation coefficient's value drastically. So knowing what that point can do, it can cause your correlation to become a lot stronger or a lot weaker. And you'll even see that a little bit in your CFUs today. All right, any questions with the notes? Come on.
Can you go back to that, like I think it was 2 pages ago where you had the range, like what would you?
Sure. Go back to this page right here. Okay.